Okay, my dear children, so happy to see you again. We are continuing the lesson Laws of Motion in Physics. This is online classes, tele classes from Riju and PSK classes. Hope you are enjoying and hope you are benefiting. Till the last class, we actually did almost most of the concept in the chapter. Fine. The last topic that we were discussing was friction. And we discussed that there can be two basic types of friction. One is known as a sliding friction and the other one is the rolling friction. In sliding friction, we studied that friction can be classified into static friction as well as kinetic friction. Fine. In static friction, we studied that the frictional force is directly proportional to the normal reaction. And we also know that static friction will vary from 0 to certain maximum value, and that maximum value is called what? It is known as the limiting friction. And the limiting friction is given by an equation. And what was the equation for limiting friction? The equation for limiting friction in terms of a coefficient of static friction is given by this equation. I wrote limiting friction as the maximum value of static friction, Fs maximum. You can call it by any other name, no problem in that. I call it like Fs maximum, okay. And that is given by a constant mu s called the coefficient of static friction into the normal reaction, okay. This is the limiting friction. And we also know that when the body starts moving, there is again friction. And that friction is known as kinetic friction. Kinetic friction also has got an equation similar to this one. This is given by mu k into normal reaction. This is maximum value of static friction, but this is the value of kinetic friction because kinetic friction is a constant. This is what we studied. Okay. For today's discussion, I want you to memorize this. I want you to remember this equation where you can even simplify that. You can call this friction, maximum limiting friction as F, then you can call it as say mu into N. So that you get mu is the ratio of the limiting friction and the normal reaction. If you know this, the upcoming discussion will be easy. Okay. And what is that upcoming discussion? That is a topic called angle of friction. It's called angle of friction. To understand what angle of friction, I am inviting you to this picture where there is a horizontal surface and there is a block kept on that one, and that is being pulled. And this is coming to motion. It's coming to motion. Okay. So when you are pulling a body which is stationary, static friction will start acting. And when will it start moving? We discussed that point. It will start moving only when the limiting friction is achieved and the applied force is more than the limiting friction. Fine. So here the picture is this. This is the applied force P, which is enough to move the body. This is known as the normal reaction, which can be written as R or N as you like. And this one is the static friction opposing the motion. And this has the maximum value of the static friction. It is called the limiting friction. And what is S? You should know that the definition of normal reaction and friction, what was that? Normal reaction is the contact force perpendicular to the surface. And what was friction? Contact force parallel to the surface. So this R and F are actually contact forces. Difference, R is perpendicular, F is parallel. So there is only one contact force actually acting, and that is this S. It is a contact force, and the vertical component of that is known as normal reaction, and the parallel component is known as friction. So S is the net contact force. You getting it? That means R and F has a resultant, and that resultant is S. S is what? It is the actual contact force. Okay. So we can say this is the contact force. This is contact force. Okay. समझ में आया? That is a contact force from the surface, and that is not perpendicular or parallel. So we have a method of analyzing this by converting that into one component here, another component here. So R is the normal reaction, which is the perpendicular contact force. F is the friction, which is the parallel contact force. And here friction is maximum. Now you can see that this resultant contact force is making an angle with the normal. You can see there is an angle marked here, theta. What is theta? Theta is angle. Angle between what? Angle between the normal reaction and S. And what is S? S is the resultant of F and R. S is the resultant of F and R, which is the actual contact force. See, what is the definition of angle of friction? You are talking about this angle. You are able to define it now. Angle theta. Look at the diagram. What is theta? Theta is angle between what? Between the normal reaction and the resultant of R and F, which is S. Now read the definition. Angle of friction is the angle between the normal reaction. So your concentration should go here. This is the normal reaction and resultant of what? Limiting friction and normal reaction. So you have the limiting friction here. This is the limiting friction. This is the normal reaction. The resultant is here. Angle between the normal. Let me draw that again. Angle between the normal reaction and the resultant of normal reaction and the limiting friction is called angle of friction. What is so big in this? Why are we going to define all this like this? Okay. Now from that diagram, you can actually think about a triangle. You can think about a triangle like this. There is a triangle like this. Let me draw that triangle here. So there is a vertical side. There is an hypotenuse, there is a horizontal side. This vertical side represents the normal reaction R and the horizontal side represents the limiting friction F, and this is the resultant S, and this angle is theta. Simply define tan theta. What is tan theta in the triangle? Tan theta is opposite side F divided by adjacent side R, F by R. But I told you a little while ago, what is F by R? F by R is the coefficient of static friction. So this is the coefficient of static friction. That's what I written. Tan theta is F by R. Tan theta is equal to mu. Or what is theta? Theta is equal to tan inverse mu. Because we know F by R is equal to mu, where mu is mu s actually. Hence, coefficient of limiting friction is equal to tangent of the angle of friction. What is the meaning of all this? I tell you. So, understood what is the relation between coefficient of limiting friction and tan theta. Like a coefficient of the limiting friction mu s is actually equal to tan theta, where theta is the angle of friction. You know, if you want to calculate friction in any case, you must be given mu. The value of mu must be given. But sometimes the examiner or the question paper setter will not give that. They will give angle of friction. For example, they give you a body of mass 2 kg being pulled by a force of 10 Newton. You just need to calculate whether this will move or not. How to find out that one? For that you need friction, and for friction you have an equation. If you want the body to move, the applied force 10 must be greater than the maximum value of friction. That is the idea. If you want to move the body, applied force should be greater than limiting friction. But how to calculate limiting friction? Limiting friction is calculated using the equation mu s in the normal reaction. You know the normal reaction here, but you don't know mu s. Instead of that, they may give you angle of friction theta is equal to 30 degree is given. Angle of friction theta is given as 30 degree. So when that is given 30 degree, you can calculate mu s. How? Mu s will be equal to tan 30, and that is nothing but 1 by root 3. So angle of friction will help you to calculate the coefficient of limiting friction. That is why we need to study this. So tell me, what is the definition of angle of friction and how is it related to this coefficient? Definition, you know, it is angle between the normal reaction and the resultant of normal reaction and friction. Tan of that angle gives you the coefficient of limiting friction or the static friction. I hope that point is okay. Okay. Now, there is one more angle that we need to study. Before that, this is like sometimes they will ask you how to calculate the resultant contact force. The resultant contact force, I told you just like previous discussion, it is equal to S. And how do we calculate S here? We know S is a resultant of R as well as F, and these are perpendicular to each other. So we can write like S is the square root of F square plus R square. Perpendicular forces resultant, parallelogram law. And we know F is nothing but mu mg. mu into normal reaction, and the normal reaction is mg. So you can substitute mu mg. Okay, I think that is clear, right? Frictional, maximum frictional force is, this will be mu s. I am not writing mu s every time, that's it. Mu into normal reaction, and normal reaction is nothing but mg. And what is normal reaction? That is mg. Now resultant of these two, S is the resultant of what? F square plus R square or N square. Either way, it's okay. F4, no problem, N square. And substitute. F square is what? Mu square, M square, G square. Plus this is again M square, G square under the root. Is there any common factor here? Of course, you have common factor mu square, G square. You can take it outside. So you will get this as, the common factor is M square, G square. M square, G square is a common factor. M square, G square, 1 plus mu square under the root. And this will come out of the root sign. So you will get mg into root of 1 plus mu square is what? It is the total contact force. The total contact force in this case is mg into root of 1 plus mu square. Suppose there is no friction, what will happen? If there is no friction, mu will become 0. If there is no friction, mu will become 0, and your answer will be mg into 1 plus 0. So that will give you mg. That's what here, when there is no friction, mu equal to 0, and the contact force will be minimum, and that contact force will be equal to mg, the weight of the body. Okay. So the contact force minimum is mg. So it can go up to maximum up to mg into root of 1 plus mu square. That is a variation of contact force between the body and the surface. Okay. Now I said from this angle of friction and contact force we are moving to another angle, and this is actually very simple. For example, if you have an inclined plane, a surface like this one, and if you have a body on it, you can see it is at rest. But what will happen if I incline it a bit? If I tilt it like this, what will happen? At a particular point, you can see it slides downward. At a particular point, this will slide downward. So that angle is called angle of repose. What is angle of repose? It is angle of the inclined plane at which a body just starts sliding down. That means at that point the body will not remain at rest, it will start moving downward. Okay. How do we analyze this thing? Okay. So what is angle of friction? It is angle of an inclined plane. I can show you another example. See, this is a book and this is my phone. I can keep it on this. It will not move. But what will happen if I incline it like this? If I tilt it, this become an inclined plane. And this inclined plane is making an angle here. You can see this angle from the horizontal. So if I keep it over this and if I tilt it like this one, you can see at a particular point it slides downward. It starts sliding downward at a particular point. That angle is called angle of repose. Angle of repose is the angle of the inclined plane, this angle, at which a body placed on it just begins to slide. That angle at which it begins to slide. Okay. Now on an inclined plane, you have this is inclined plane. There is a body on it, and we know that weight of the body will act in the downward direction mg, vertically downward, and the normal reaction will act in this direction. Fine. Now we can resolve mg into two components. One is mg sin alpha, another is mg cos alpha, because angle is given as alpha. Okay. Now frictional force will act. If there is friction on the surface, frictional force body will tend to slide downwards, so frictional force will act in the upward direction. Okay, there is no acceleration in this direction. You saw my phone, the phone does not move up or down the plane, it was moving along the plane. So this r and this mg cos alpha will cancel, they will be equal. That's what it written here. Okay, r equal to mg cos alpha, r equal to mg cos alpha. Now, if mg sin alpha is greater, then this will accelerate downward, it will speed up, its speed will increase. Clear? If f is more than mg sin alpha, it will not move at all. It will not move. Fine. Now, if it is just sliding downward, it means that the net force acting on that direction is also 0. That means mg sin alpha is just equal to f. That means it can have a uniform motion. That's why we say just begins to slide. There is no acceleration, but it is just moving. Net force is 0. So we can write mg sin alpha is equal to f. Okay, so that is why f is equal to mg sin alpha and r is equal to mg cos alpha, the two relation that we have. Now you can try dividing first equation by second equation. What will you get? You will get f by r is equal to tan alpha. What is f by r? I told you today class starting, I told you f by r is nothing but limiting friction divided by normal reaction. That is nothing but coefficient of limiting friction. So you will get mu equal to tan alpha. But we already proved that mu is equal to tan theta, where theta is angle of friction. Don't confuse. Theta is angle of friction, alpha is angle of repose. Angle of repose. Okay. So here I am proving that f by r is equal to tan alpha. Previous I proved that f by r is equal to tan theta. That means tan theta equal to tan alpha. If the body is just sliding down, that means angle of repose is equal to angle of friction. Okay, angle of repose equal to angle of friction. Now, coefficient of limiting friction is equal to the tangent of angle of repose. So, you have two relations now. What are those two relations? One, suppose that mu is the coefficient, then this can be written as tan theta, where theta is the angle of friction. And we can also write mu equal to tan alpha, where alpha is the angle of repose. That means angle of friction and angle of repose are equal for an inclined plane. These two are equal. Okay. For example, okay, I will make this clear. Don't worry, I will make this clear. For example, imagine that for a surface you are given angle of friction. Sorry, for a surface you are given angle of friction. You are given angle of friction as 30 degree. Angle of friction as 30 degree. What do you understand from this thing? You should understand that if the surface, if that plane has got an angle 30 degree, if the surface is made at 30 degree, the body will slide down. That is the meaning of it. Angle of friction is equal to angle of repose, and at repose angle this will still slide down. So if you make that plane at 30 degree, it will slide downward. What will happen if that plane is given an angle less than 30 degree? See, it will start moving only at 30 degree, but if the angle is less than 30 degree, it will not be moving, it will be at rest. And if the angle is greater than 30 degree, what will happen? This will move faster downward, it will get accelerated. So that is why you understand angle of repose. So what is the, like in exam they can ask you, differentiate between angle of repose and angle of friction. Angle of friction is the angle between the normal reaction and the resultant of normal reaction and the friction. What is angle of repose? It is angle of the inclined plane at which the body will just start sliding down. Imagine for a moment that you are driving your car, and you see, you are driving your car and somewhere you stopped your car on an inclined road. So there is a road going uphill and you parked your car here. Okay. And assume that the coefficient of friction here between the tire and the road is nothing but 1 by root 3. And assume that this road has an inclination of 40 degree. Ab kya hoga? What will happen? If you can answer this, you understood this, otherwise you don't. Now I will tell you, this is coefficient of friction. Mu is 1 by root 3. So from that we can use the idea that tan theta is equal to mu, which implies that since mu is 1 by root 3, that means theta should be equal to 30 degree. What is theta? Theta is angle of friction. I got angle of friction 30 degree. And we should know that angle of friction equal to angle of repose. That means at 30 degree, the body will start sliding down. And the angle is 40 degree. So what will happen? It is more than 30, so your car will not stay there. Even if you apply brake, the handbrake, everything, the car will not stay there. The car will skid downward. Because the practical angle of that plane, 40 degree, is greater than the maximum angle up to which the body can be at rest. And that maximum angle I calculate as 30 degree. That is angle of repose. Assume that here the angle is 20 degree. Suppose it is 20 degree here. Practically it is 20 degree. You need 30 degree to slide down, and this is a 20 degree. You can safely park. Be confident. Nothing will happen to your car. It will stay there. This is applicable even in mountaineering, like you are climbing a mountain. Okay, you are climbing a mountain. At every point, this will work. Every point this will work. If the inclination is, the practical inclination is more than the repose angle, you will slide down. Whatever you do, you will slide down. All right. Okay. Now let me give a few diagrams where you compare this. Okay, watch carefully. Watch carefully. Watch carefully. I am giving you 3 inclined planes. Okay, one like this, one a bit like this, and the third one a bit like this. Okay. Now this angle of the incline, this angle of the incline, let me call this angle as beta. Okay. Everywhere I am calling beta. Everywhere I am calling it as beta. It is the angle of that plane. Okay. Assume that here coefficient of static friction is given by 1 by root 3. Coefficient of static friction is given by 1 by root 3. So immediately what you understand? Immediately this will tell you that tan theta, which is the angle of friction, equal to 1 by root 3, which will imply that theta is equal to 30 degree. What does it mean? The coefficient of the angle of friction is 30 degree. So when angle of friction is 30 degree, immediately your brain will tell you, angle of repose alpha, angle of repose alpha is 30 degree. Immediately your brain will tell that if the inclination is 30 degree, the body will start sliding. If the inclination is less than 30 degree, the body will not slide. If the inclination is more than 30 degree, the body will accelerate. Okay. Assume that in the first case here, say this angle is 20 degree. And the second case, this angle beta equal to 30 degree, and the third case beta equal to 40 degree. Okay. Now I place a body here, and I place the same body here, and I place the same body here. What will happen? Okay, you have to compare this thing, alpha. And how did you get alpha? From theta. Theta is equal to alpha, so alpha equal to 30 degree. 30 degree is the minimum angle required to slide down, and this is less than 20. So this is simply like this one. I can say angle of the plane is 20 degree. Angle of repose is 30 degree, which is rather, I'll write in the other way. Okay, fine. 20 degree is less than 30 degree. So what will happen? Body will not slide. Will not slide, it will be at rest. Second case, what happens? Here both are equal. Okay, both are equal. So the body will just slide. It will just slide down. When it just slides down, understand that it means that its acceleration is 0. Acceleration how much? 0. And in the third case, since the given angle is more than 30 degree, the body will accelerate downward, will speed up downward. Speed up means speed keep increasing, speed up downward. Under which of this condition will you park your car? Like this, or like this? That's the point. Okay, I hope that you understood this. But this can come in examination in a wide variety of fashion. Understand the concept first. Take an inclined plane and work out something like this practically so that you understand that. Now one challenge. I am giving you a surface, a plane and a body. How to find the coefficient of friction between them? How to find coefficient of friction between my phone and the book? How to find the coefficient of friction? Work out. This is to test whether you have understood angle of friction and angle of repose. Look at the question. There is an inclined plane, angle 20 degree. There is a block, okay, say mass 2 kilogram, and this is tied by a string to a fixed support. It is given that coefficient of friction mu s equal to 1 by root 3 for the body here. So at this point, coefficient of friction is 1 by root 3. Fine. Now question is, what is the tension in the string? What is the tension in the string? How to answer this? First of all, understand that there will be a tension in the string only when the body tends to slide downward. If it slides downward, the string will prevent it by applying a force. That force is called tension. And if the body does not move downward by itself, then there is no tension. Understand that point. Now for this, see the value mu s. What is mu s given as? Mu s is given by 1 by root 3, which implies that angle of friction tan theta 1 by root 3, which implies that theta equal to 30 degree. Is that okay? Now connect this to angle of repose. That means this body will slide down or will start sliding down only when angle of repose alpha equal to theta, so alpha must be equal to 30 degree. That means only when the inclination is 30 degree, the body will have a tendency to slide downward. Now see the angle, it is 20 degree. We can say given angle is less than angle of repose. Therefore, the body has no tendency to move down. That means even if you cut the string, the body will not move. That means the string is not required. That means there is no tension, there is no force acting in the string. Is that okay? So answer, tension is 0 here. There is no tension in the string. But what will happen if you increase this angle to 40 degree? What will happen if you increase this to 40 degree? Then we will know that the body will start sliding downward. There will be a net force acting downward and the string will now prevent it. So there will be a tension in the string. And the tension can be calculated like the force will be equal to mg into sine 40 degree. That is the force acting downward. And the frictional force is the limiting friction F. The difference between them must become the tension, frictional force. The difference between mg sin 40 and F will give you the tension in the string. Okay? So practice this, make the idea perfect. You studied this term, frame of reference, in the chapter motion in a straight line, and there you were taught that it is a coordinate system with a clock. Coordinate system to measure position, clock to measure time, to understand how fast or slow bodies are moving. Now we are going to extend it a little more. Frame of reference and the classification. Okay, what is frame of reference? Same revision, I am just doing the revision. A frame in which an observer is situated and makes observations is known as frame of reference. It's like a viewpoint. A car is moving. You can watch the moving car, or the driver in the car can watch you. So you can say like this, in the frame of reference of myself, the car is moving. In the frame of reference of the person in the car, I am moving backward. So this, so you use the word frame of reference. From the frame of reference of myself, this body is at rest. But from the frame of reference of moon, this body is moving with the earth. You got my point? So that is the meaning of frame of reference. And the frame of reference always has got a coordinate system x, y, z to tell which position it is, and a clock or a watch to measure the time. Okay. Now there are two types of frame of reference, that's what I am going to tell you. One is known as inertial frame of reference and the other is called non-inertial frame of reference. Okay. Before I continue, let me tell you a story. It's not a story actually. Assume that you are in a car. Your dad is driving the car. You are in the back seat. Okay. The car is going in a straight road. You simply sit quiet. You are maybe you are in your Insta. Okay, you are in Insta. Suddenly, if your father takes the car to the left, suddenly he turns that to the left. Suddenly, without any notice, suddenly he turns to the left. In which direction will you fall? In which direction will you fall? The car was going straight. You are sitting comfortably. Suddenly, your dad takes it to a left turn. In which direction will you fall? You always tend to fall in the outward direction, right? It's not a big deal. Every time we observe this, we feel, we experience this. And we are going to relate that situation to these technical words. Inertial frame of reference and non-inertial frame of reference. Okay, what is that? Inertial frame of reference means it's an observer, and the observer must be either at rest or in uniform motion. An observer who is either at rest or in uniform motion is an inertial frame of reference. Like if I watch something by standing here, I am an inertial frame of reference. If I am sitting in a car and going in a uniform motion, constant velocity, same speed, same direction, then I am an inertial frame of reference. Whatever I watch is from inertial frame of reference. See the second point. In inertial frame of reference, Newton's laws of motion holds good. That means Newton's laws of motion can be applied only when the frame of reference is either at rest or in uniform motion. This is also known as Newtonian or Galilean, doesn't matter, that's not very important for you, but that's why we call it. Okay, now we have done this in the lift problems. Okay, a lift at rest or a lift which is moving up down with a constant velocity, a car moving with a constant velocity on a straight road, all of these are called inertial frame of reference. You know, when a lift is at rest, you get the actual weight. When it is moving up with a constant velocity or down with a constant velocity, you get the actual speed, actual weight. Okay, that is what we call as an inertial frame of reference. Everything observed from the ground of Earth is assumed to be inertial. Earth is actually practically not inertial, but we are assuming Earth to be inertial. So whatever we observe from the ground, it is not considered as the actual one. The velocity of a car with respect to man on the ground is considered as actual velocity of the car. We assume Earth to be at rest. Got the point? We assume Earth to be at rest, then we watch. Okay. What is the other frame of reference called? It's called non-inertial. It's called non-inertial. And what is a non-inertial frame? An accelerated frame. Oh my God, that's it. If the observer is accelerated, that means observer's velocity is changing, then he or she is a non-inertial frame of reference. I told you earlier, you are sitting in the car and your dad is taking it to the left, suddenly a circular turn. When he is in a circular turn, his velocity changes. So you are watching everything, but your velocity is changing, you are accelerated, then you are a non-inertial frame of reference. See that point? The car was going straight on a straight road, constant speed, then you are an inertial frame. But when the car takes a left turn, a right turn, suddenly accelerates, suddenly retards, then you become a non-inertial frame. Because a non-inertial frame means accelerated observer. Accelerated observer means then you will see things that are not explainable using Newton's law. So Newton's law is not applicable in such situations. For example, I told you, when your dad takes a left turn suddenly, you tend to fall outward. You experience this, right? But actual force is to this side. Actual force is opposite to what you experience. That's why we say Newton's law is not applicable, because you are experiencing a force which is actually not there. Oh my God. You are experiencing a force which is actually not there. You experience an outward pull, but the actual pull is inward, but you don't experience that. You don't experience the actual force, but you experience something which is not there. I could call it as a ghost force, a preda force, predam, force in the predam. You feel outward, the ghost. Because that is a non-inertial frame where Newton's law is not applicable. Wow. There is at least one point where Newton is defeated. You can challenge, oh Newton, you are so great, but your law is not applicable here. A car moving in uniform circular motion, a car is in a circular motion, then that is a non-inertial frame. You cannot apply Newton's law. A lift which is moving upward or downward with some acceleration, then you see, like I told you, when the lift is accelerating upward, you experience more weight. When it is accelerating downward, you experience less weight. These things are because of the nature of the frame of reference. Not very important in theory examinations, but of course in questions, while you solve questions, this can help you solve easily. Application of this thing can help you solve easily. Okay. Now that is what we are going to do. This is an exercise from NCERT textbook. a very complex exercise. People complain that they don't understand it very easily. So I am trying to give you a very good insight of solving this in two different methods. The rear side of a truck is open. There is a truck where the back side is open. A 40 kilogram box is placed, you can see the box over there, 5 meter away from the open end. That means from the rear end to this side, that is 5 meter. The coefficient of friction between the box and the surface is given as 0.15, box and the surface. On a straight road, the truck starts from rest and accelerates. So this is accelerating, it's speeding up with 2 meter per second square, that minus 2 is here, meter per second square. At what distance from the starting point does the box fall off the truck? Let me translate this. The truck was here, stationary, box is kept there. Then the driver started the truck, he started giving acceleration, so speed keep increasing. When the speed keep increasing, the truck will go forward. And what you practically see is this, as the truck moves forward, you will see that the box will start sliding backward. And when the truck reaches somewhere here, the box will fall off the truck. That means the box which was here will reach the end here and will fall downward. Okay. Now it can tell you there can be two observers. One observer outside on the ground, and that is an inertial observer who actually see the reality. And you can have one observer on the truck who will actually see the ghost forces, the Preda force, right? And I'll tell you what actually happens. For an outside observer, this is what is going to happen. For the outside observer on the ground, he will see the truck and the box here. But after some time, he will see that the truck has gone forward, the box also has gone forward. But what happens is that due to some reason, the truck's acceleration is more than the acceleration of the box. So the truck will cover a larger distance, the box will not be able to cover that one. So what will happen? The distance between the truck and the box will change. I can mark it here. Okay. So for an outside observer, this was the initial position. So the truck, okay, take any one point of the truck, take the top, okay, maybe this point on the truck, take this point on the truck, and that point has reached here. You can see that mark here. This is the point. So that point traveled forward. This is the distance traveled by the truck. What about the box? The box was here, this point, and the box is now here. So this is the distance covered by the box, SB. And from the diagram you can see there is a difference between these two. And what is the difference equal to? The box which was here literally moved backward. But actually the box did not go backward. You have to know that. Box did not go backward. Box also went forward. The truck also went forward. മക്കളെ ശരിക്കും ശ്രദ്ധിച്ചോ. The box did not go backward. The box went forward. The truck went forward, but the truck was faster. So he covered more distance than the box. So what happened? There is a difference. The box which was there here almost at the middle of the truck, now is at the end. And in the next instant what will happen? That the box will fall out because it cannot catch up with the truck. And this difference is 5 meter as per the problem. Okay, so I can write an equation here, ST minus S box is equal to 5. You can solve it. This is the actually reality as seen by somebody outside. This is the viewpoint of a inertial observer. You can apply Newton's law very clearly. Okay, now I will show you another picture where the observer is on the truck. Observer is on the truck where the box was placed. Assume that the observer does not slip. Okay, assume that the observer is firmly connected to the truck. He is like bolted to the truck. Okay. Otherwise you may ask, when the box falls, why doesn't the man fall? Okay. So the person was here, the box is here. The truck started moving forward. After some time the person is at the same place and the truck is here, the box is here. So initially there was no distance between the box and the man, but now initially there was no difference, but the difference is now 5 meter. Next instant what will happen? The box will fall out. the box covered 5 meter. In which direction? The box for this person, see, he was standing somewhere and there was a box. After some time when he watches, he is still there, but the box is there. In which direction? He will say the box has gone backward against the motion of the truck. The truck is moving in this direction. He will say, no, there is something pulling the box in that direction. He will feel the same feeling that you had in your car when your dad was taking it to the left turn. When the dad was taking a left turn, you suddenly felt an outward force, right? The same force is experienced here. The person stands here, he will feel that, okay, there is some ghost force which pulls the box backward, which actually is not the reason. So for this person, with respect to the truck, the box has gone backward. Okay. So you can see that. So that means for this person, he will feel there is a force acting in that direction, the box is going backward. From the viewpoint of a person who is accelerating with the truck. I told you, he's got bolted to the truck, so his acceleration is same as that of the truck. So he is watching box and he is an observer, and this observer is not at rest, he is accelerating with the truck. So he is a non-inertial frame of reference. And this man will see that force which is not present actually, a backward force. So we will solve this tomorrow. Please try to solve this by yourself. Okay, bye.